Hello, my name is Theodoros. I'm a software architect. I work in software the last 15 years, and I would like to present the project that I did for the course of data science with Python in Nomades, and basically the proof of concept that I did as part of this project. The title of the project is Algorithmic Trading of Swiss Stock Market with Stock Prices and Stock Fundamentals Data. And I will start with how I gathered the data. I used a website, it's called eodhd.com, where I took a subscription model and I downloaded the fundamentals and the prices data for Swiss Stock Exchange for all the stocks that it includes. And then I apply some transformations on top of this data. So basically I added some features. I flattened the files, so I combined JSON files with CSVs. I created common files. I created new features like the capitalization and P to E and other indicators of a stock. And in the end I created a single big file for the whole exchange. Then I took this file and I loaded it into a Google Colab project based on Jupyter, where I used scikit-learn to create a linear regression model so as to be able to predict the stock capitalization based on the fundamentals data of the stocks. And when I trained this model and I had the model, I apply the prediction for each stock, and I was able to predict the capitalization of the stock for all the quarters, for different quarters for the last 30 years. And when I was seeing a big difference between the predicted capitalization minus the actual, I was creating trading signals. So for instance, if the capitalization was lower than the actual, it means that probably the value of it's a little bit undervalued, the stock. So I was creating a buy signal. And for the opposite, I was creating a sell signal. And this way I was able to create for each stock of the Swiss stock market buy and sell signals. And after, in order to, let's say, to test this hypothesis, I matched the buy with the sell signals, so basically the two legs of the trades, and I created a performance of this trade, and I compare the performance of each trade with the performance if I was trading for the same dates the SMI index. So basically I use SMI index as the benchmark of my study, and I'm trying basically to win against the benchmark, basically to create better returns. And based on this study, and by doing also on top some grid search in order to fine-tune the way that the model is working, I was able to produce multiple times the SMI index performance in almost consistent way. So for almost all setups, I was able to create better performances.